Alright, in problem number 8, we're asked to evaluate an improper double integral. Okay, so this is the integral of the function y e to the negative y squared all over x squared plus 4. And x varies from minus infinity to infinity, and y varies from 0 to infinity. Okay, so as far as the region of integration, well, x can take on any real number, and y can take on any non-negative value, right? And so putting those two together, we're describing this upper half plane, including the x-axis there. Okay, so we're integrating over this infinite region, and one thing that can help in this particular problem is to first notice that our integrand is of a special form. If you go back to the problem number 1 video, okay, we said the following: if your integrand is of the form where you have a product of two functions where one of the factors depends only on x and the other factor depends only on y, then you can split up an integral like this as the product of two single variable integrals. Okay, so I called, say, the function that depends only on x, g of x, and the function that depends only on y as h of y. And so in that video I said, alright, now we can write this as the integral of our g of x, our 1 over x squared plus 4. And here x varies from minus infinity to infinity. And then we can multiply that with the integral from 0 to infinity of y e to the minus y squared. Okay, so this is nice, and that now we can go ahead and just focus on each individual piece on its own. So I'll call this, say, integral 1, and the second integral 2. And we can just compute these separately off on the side, and then the value of our integral here is just going to be the product of those. Okay, so let's go ahead and do that now over here. So for 1, the key thing to know is that integrating something like 1 over x squared plus a squared, this is an arctan integral. It's 1 over a arctan of x over a plus c. So in particular, if I want to say integrate 1 over x squared plus 4, that's going to give me, well, a would be a half, or sorry, a would be 2, so I'm going to get a half times the arctan of x over 2, and now we're letting x vary from from negative infinity to infinity, right? So if I go ahead and take the limit of the arctan as the value of x goes to infinity, that's going to give me a limiting value of pi over 2. Okay, so what I'm going to do here for the moment is I'm going to pull out this 1/2, and then taking that limit of the arctan as the argument goes to infinity, that's going to give us a pi over 2. And then what I'm going to do is subtract from that the limiting value as I let x approach negative infinity, and that's going to approach negative pi over 2. And so here in parentheses I'm going to get pi over 2 plus pi over 2, so that's just pi, and then I have the half out front. So this integral here for number 1 is equal to pi over 2. So I'll put that down right here. Okay, so now we need just the value of this second integral here. Okay, and I don't think I have quite enough room down here, so I'll do that over here. And so we're going to integrate from 0 to infinity y e to the minus y squared dy. And the key here is to note that, well, we have a y out in front, and the exponent is a negative y squared. And the derivative of y squared is 2y. So that suggests a substitution, set u to y squared. So then du would be 2y dy. Or put another way, we could say that du over 2 is equal to our y dy, right? So this part here is going to become our du over 2. The e to the minus y squared, that's just going to be e to the minus u. And then we're integrating from where to where? Well, let's change the limits of integration. So if y is 0, then u would just be 0 squared, so that'd be 0. And if we let y approach infinity for this upper bound, well then u, which is y squared, will also certainly approach infinity. Okay, so now, just about there, this is going to give us minus a half e to the minus u, and we're letting u vary from 0 to infinity. So now as I let u approach infinity, the exponential is going to drop out, going to approach 0 in other words. And so then I'm going to get 0, and then if I evaluate at u equals 0, I'm going to get a 1. And so minus a half times a minus 1, that's going to give me 1/2. Put that down here. Okay, great. So there then is our second factor. So putting that all together, what's the value of our integral? It'd be pi over 4. Alright, so that's going to do it for this video. Alright, thanks.